Here's my video for the people who want to really understand what's going on. If you're gonna go to AP Chem or have a college class in Chem at any point, I would go through this. Don't be afraid to hit pause and have a think, and please ask questions in the comments or email me. So here's the basic deal, people. Water sits around, but the weird thing to know is that it sometimes falls apart. And if you grab water apart, what you tend to get here is, see, you get H plus plus OH minus, because that's two H's and one O, right? Furthermore, what you really get is this. This is really the equation, but everybody tends to write it like this because it's easier, but really what happens is one of the H's leaves one of these and goes on to another one. And what you then have is three H's and one O. But then one of the waters gained an H plus, so now it's not neutral anymore. It's not charged zero, it's positive. And what remains is water that lost an H plus. So it only has one H, it has one O, and now it's minus 1. At 25 degrees Celsius, which is our standard reference temperature for all these things, and the AP test keeps using 25 degrees Celsius, it turns out that water will fall apart so that you get 1 times 10 to the 7 negative 7 molarity of each of these. Of course, if you get one of these, you also get one of those. And this just happens to be the nature of this universe. If you have pure water, we're always going to pretend it's pure water. Then you get this molarity of this one and this molarity of that one. 1 times 10 to the negative 7, because that is the way it works. And just in case you're forgetting how that works, what that means, I mean this. 6 zeros after the decimal, that's 6 zeros. So the 1 is in the 7th decimal place, less than 1, right? And the molarity is moles per liter. Or you also see it, of course, written like this. So these are all the same thing. And you probably had some 8th grade teacher or something that told you that pH of 7 was neutral, which we'll get to in a minute about pH. But if you have equal numbers of both of those, both of these, or sometimes written as this, then it's neutral. It's not especially acid or base, either way, it's neutral. The next point is that talking about these numbers when they're so small gets to be a real headache. So what we're going to do is we're going to introduce logs here. And log of 10 to the negative 7 means 10 to the what power will get me 10 to the negative 7. When you take the log, you're asking what exponent you got to stick on 10 to get the number under discussion. Sorry. What number do I have to use it as an exponent on 10 to generate 10 to the negative 7? Well, of course, the exponent you got to stick on there is negative 7. So the answer is negative 7. However, most people are really bad with negative numbers. And if we give negative numbers to the average person, they will kill the fish or make the swimming pool unusable or something. So what we're going to do is we're going to do a tiny bit of a mathematical cheat, make it easier for everybody to understand. And what we're going to do is we're going to say that pH is the negative of that answer. Remember we just did the molarity was 10 to the negative 7? And we said log is negative 7? But pH is the negative of that answer, so that we give people positive values. So the pH of this is not negative 7, it's the negative of that answer. The pH is 7. pOH is all the same math, it's just that you start with the OH minus molarity, and it's all the same thing. So 10 to the negative 10 to the what power will get you negative 7? Of course, the answer is 7, but pOH is the negative of that answer, so pOH is positive 7. This is just a law of nature, and if you get more of this, it combines with that, or maybe it's easier to visualize here. If you get more of this, it tends to combine with that and make water. So if you push this up in concentration, this goes down in concentration, and the opposite. If this goes up, that must go down. They must head in opposite directions, and the concentrations in the brackets means molarity. The brackets is another way of saying molarity. concentrations multiplied together must be 1 times 10 to the negative 14. And since we know that the concentrations were that, right, and that pH at the P numbers, the pH and the pOH at that point were 7, it also mathematically means that pH plus pOH equals 14. For instance, if you knew that pOH was 10, what is pH? But they must add to 14. So 14 minus 10 equals 4, the remaining part of 14, right? And that is pH. Also, you can do it by the multiplying problem here. So if I knew that this is 1 times 10 to the negative 6, and I didn't know OH minus, could I figure it out? Well, I know that they must multiply to be 1 times 10 to the negative 14, which means I can solve for x by dividing this under, and I get this. And here's another way to rewrite it. And what we can do is we can split these up, and I covered this early on in the semester, in the beginning of the school year really, and you can kind of split them up right here, and I get 1 over 1. And here's the trick on the exponents on 10. When you're dividing, what you do is you subtract the denominator exponent. So what we're going to have is 10 to the negative 14 minus the minus 6, which means we get 1, because this is 1, times 10 to the negative 8, because this is negative 8. And that was equal to x, right? But what was x? X was the OH minus molarity, and brackets means molarities, concentration, strength, dissolved strength in water. So when we have pH, what we really have is the exponent on 10. Remember, we found the exponent on 10, then we changed the sign. If we want to run this backwards, what we can do is say, I remember that pH is the exponent on 10, except the sign is wrong. So if I want to go from pH back to concentration, molarity of H+, what I can do is use the 9, put the negative back, because remember we cheated for grandma, put the negative sign back, and use it as the exponent on 10. And I get 10 to the negative 9, which is 8 zeros there and 1 decimal there. Also, this gets a little complicated and it depends on your calculator, but I'm going to show you on mine here. What would I do? If pH is 4.3 and I want to find H plus molarity, I have to take this number, put the negative sign back on first, and put it as the exponent on 10. And on this calculator, what I do is shift, because you see the 10x there? I know it doesn't look like it, but that's an exponent x there. So I'm going to say, I'm not asking for the exponent on 10 calculator, I'm giving it to you. Onto 10, put the exponent of negative 4.3. And I get 5.01, and don't forget this part, times 10 to the negative 5. And that is the molarity that generated the pH in the first place.